In this StorPool demonstration, we're going to look at temporary media ejects and recovery. We have three open windows. The first will run an FIO task to create load on a test volume. The second window will show the IO throughput, and the third will be used for our commands to display the output. So first, let's start FIO on a test volume. This will generate write IO load on a volume called FIO-hybrid and run indefinitely. After the 10-second ramp up, we can see the IO generating around 220 megabytes a second. Now let's look at the configuration. We're going to remove at disk 114 a 2 terabyte hard drive. The live volume is FIO vol-hybrid, a 300 gigabyte LUN with 3 mirrors, one of which is on HDD. To show there's active data on 114, we'll list the active IO requests. We can see multiple 4K IOs that correspond to the FIO specification. Okay, let's now eject disk 114 using the StorPool CLI, simulating a drive removal. Our disk list shows that drive 114 has been removed from active use. More importantly, multiple volumes, including our test volume, now show reduced redundancy due to the missing drive. That's indicated with a D flag in that column. We can also show that there's no active requests on 114, although our FIO continues in the background. With another StorPool command, we can list the status of drives on this node. Disk 114 shows as recognized but ejected. Assuming the drive loss was only temporary, like removing the wrong drive, we can re-add 114 by the Linux device name. StorPool now runs a background task to rebuild 114, leaving unchanged data in place and updating blocks of data that changed since the eject occurred. We can monitor this with the task list command. Here we can see the recovery task in place at around 3% completed. Listing our back-end disks again, we see 114 in place with the original utilised capacity. As the recovery progresses, our logical volumes start to become fully protected again and lose the D flag. There are still some to go, but you can see here that most of them have completed. In our test, to speed up the recovery completion, we'll stop the FIO volume creating additional work. That will make the recovery run quicker. Eventually, our recovery task completes, and a quick check of the volume shows once again they're fully protected. All of this occurred in the background with active load on the system. And that completes our recovery test.